Hello, I'd like to give an overview of this merge request. It adds connection upgrade support. HTTP RFC defines an upgrade mechanism, a way for a client to request a connection upgrade to a different protocol so that client and server can speak something else, not HTTP, if the upgrade is successful. It works by client sending a request with an upgrade header, listing protocols in some preference order that it likes to switch to. And the server picks one of them in not necessarily the first one, but the one it prefers out of these, and responds with 101 switching protocols status. It can also ignore the upgrade request, just responding normally as if there is no upgrade header at all. So this merge request adds support for this mechanism so that we can support WebSockets and SPDY and anything else in our Kubernetes reverse proxy, and potentially any other things we might want to proxy in the future. So I'd like to look at the code and go through it to explain how things work on a high level. So first of all, we already have the proto definition for the HTTP protocol itself. It's probably not the most generic definition, but it's good enough for us. So we define the request and the response. And request consists of the header, which describes the request, like, the method, the query parameters, the URL path, the headers, some extra, which is specific to the protocol, the endpoint that is being called. We pass impersonation information here, for example. Then we add the upgrade flag if the client wants to upgrade. And then after the header, the client sends the body of the request and the trailer to finish the body as a signal that the body is ended. And then that's the new thing, the upgrade data. Each message may contain one of these, basically, and we encode that here. And the response is kind of the same thing. There's the only difference is here. The header contains only the response, and that's it. Then we already have this generic helpers, the inbound HTTP proxies turns an inbound HTTP traffic into a gRPC request. And then on the other end, we have this inbound gRPC to outbound HTTP. This is what runs in the agent. It turns that gRPC stream into an HTTP request to the Kubernetes API server. So we modify this to support upgrade, basically. And then we make use of them in Kubernetes server proxy. So the server is what is the part that runs in CAS. Yeah, no modifications here, basically just some tweaks, because it delegates to the HTTP2 gRPC proxy. Somewhere here. This pipe streams thing. Yeah, inbound HTTP to outbound gRPC. So you see, this thing is generic. We didn't need to modify the entry point at all. Like I just tweaked some timeouts. And here the idea is that we send the request. Yeah, we're not going to go into the code. That's not that important. Have a look at the MR, but we just send the request, get the response, checks that it's 101, switching protocols. And if so, then we start like proxying the connection directly, underlying connection. And there's a bunch of machinery that this involves. On the server, we use something that's called where is it? Hijacker. Basically, it allows you to take full control over an HTTP, of an incoming HTTP connection, and then the server like fully relinquishes control. You do whatever you need to do with this connection. Server just pretends it doesn't know anything about it. So you are in full control, and you can read and write anything does need to be HTTP. So this is on the server, and on the client, I mean, not client, the agent, we use a client that we use a transport that makes a request and preserves the connection, and it's here. It should be round trip. Should probably rename it into upgrade. So it's the upgrade round tripper. So it makes a request, reads the response, and then if it was a upgrade request, well, in any case, it puts the connection into the field, and then the code can use that underlying connection of the HTTP client to do whatever it wants. For example, proxy the TCP stream. That's how things work here. And everything else is kind of plumbing, nothing very interesting. But yeah, let's look at how it works. So I have CAS here running and the agent running. So I have plenty of errors here because I don't have GDK running. I commented out authentication so that I don't need GDK. And my CAS just always allows the requests, and it can't sense user statistics because of that. So let's try Lens and see if it works. And I'll open the agent logs, but you can see that something's happening. And this is our CAS cluster. I created a config to talk to CAS for kubectl or anything else like Lens, and we will use that. As you can see, things are starting here, and you can see Lens is making different requests, like fetching services, and where is it? Establishing watches for nodes and pods somewhere here. This is a watch for namespaces. So yeah, it's just the way it works. And I don't have a lot of things here. It's just a Rancher desktop server, Kubernetes server without anything in it. And that it only has like 3 pods. So this is the one that contains a shell. So I can open a shell, like it has a shell binary in there, sh. So yeah, this is it. It works. And oops, and we can run top to see the processes there, and whatever, works fine. Exit, then we can do that again. or we can get logs, for example. Yeah, it's, I don't know, it's trying to do something that doesn't work, that pod itself. Anyway, that's the demo. Thank you.